Operating System, OS, Chapter -1. History of Operating System. The first generation, 1940s to early 1950s, no operating system. All programming was done in absolute machine language, often by wiring up plug boards to control the machine's basic functions. The second generation, 1955 to 1965, first operating system was introduced in the early 1950s. It was called GMOS, created by General Motors for IBM's machine. The 701. Single stream batch processing systems. The third generation, 1965 to 1980, introduction of multi-programming. Development of mini-computer. The fourth generation, 1980 present day, development of PCs. Birth of Windows/Mac OS. What is an operating system? Computer system equals hardware plus software. Software equals application software plus system software, OS. An operating system is a system software that acts as an intermediary/interface between a computer and the computer hardware. Operating system goals: execute user programs and make solving user problems easier. Make the computer system convenient to use the computer hardware in an efficient manner. The structure of computer systems. Accessing computer resources is divided into layers. Each layer is isolated and only interacts directly with the layer below or above it. If we install a new hardware device, no need to change anything about the user/applications. However, you do need to make changes to the operating system. You need to install the device drivers that the operating system will use to control the new device. If we install a new software application, no need to make any changes to your hardware, but we need to make sure the application is supported by the operating system. User will need to learn how to use the new application. If we change the operating system, need to make sure that both applications and hardware will compatible with the new operating system. Computer architecture. Special buses, roads, connecting all input/output devices to motherboard. Goals of the operating system. There are two types of goals of an OS, i.e. primary goals and secondary goal. Primary goal. The primary goal of an OS is to provide a user-friendly and convenient environment. We know that it is not compulsory to use the operating system, but things become harder when the user has to perform all the process scheduling, and converting the user code into machine code is also very difficult. So, we make the use of an OS to act as an intermediate between us and the hardware. All you need to do is give commands to the OS and the OS will do the rest for you. So, the OS should be convenient to use. Secondary goal. The secondary goal of an OS is efficiency. The OS should perform all the management of resources in such a way that the resources are fully utilized and no resource should be held idle if some request to that resource is there at that instant of time. What does an OS do? 1. Process management, Chapters 3. At a particular instant of time, the CPU may have a number of processes that are in the ready state. But at a time, only one process can be processed by a processor. 2. Memory management, Chapters 4. For the execution of a process, the whole process is put into the main memory and the process is executed, and after the execution of the process, the memory is freed and that memory can be used for other processes. 3. Device management, Chapters 5. There are various I/O devices that are present in a system. Various processes require access to these resources and the process should not directly access these devices. 4. File management, Chapters 6. there are various files, folders, and directory system in a particular computer. All these are maintained and managed by the operating system of the computer. 5. Security and protection, Chapter 7. Operating system mode. The user mode is ConcertNet with the actual interface between the user and the system. It controls things like running applications and accessing files. The kernel mode is ConcertNet with everything running in the background. It controls things like accessing system resources, controlling hardware functions, and processing program instructions. System calls use it to change mode from user to kernel. Terms related to OS kernel system call starting and operating BIOS UEFI kernel kernelless a software code ethit reside in central core of OS. Ethis complete a control over system when operation system boots kernelless first part of OS to load in main memory. Kernel remains in main memory for entire duration of computer session. The kernel code is usually loaded in top protected area of memory. Kernel performs its task like executing processes and handling interrupts in kernel space. User performs its task in user array of memory. This memory separation is made in order to prevent certain kernel data from interfering with each other. Kernel does not interact directly with user, but it interacts using SHEL and other programs. Kernel count. Kernel includes -1. Scheduler. It allocates the kernel's processing time to various processes. Point 2. Supervisor. It grants permission to use computer system resources to each process. 3. Interrupt handler. It handles all requests from the various hardware devices which compete for kernel services. 4. Memory manager. Allocates space in memory for all users of kernel service. Kernel provides services for process management, file management, I/O management. Memory management system calls are used to provide these type of services. System call is the program adequate in waka computer program / user application requests a service from the kernel of the operating system on wakaitis executed. Application program is just other process. To eto securitizations user applications are not given access to privileged resources. The onus control led BOS. When they need to do any or have a some more memory or spawn a process or way personal / interrupted requests operating system to facilitate all these. This request is made through a system call. System call serial so called software interrupts. Starting an operating system, booting. Power on switches and electricity to the motherboard or call it voltage good line. If the power supply is good then BIOS, basic input / output system, chip takes over in real mode. CPUs and like capability of using approximately 1 M buff memory built into the motherboard. The BIOS will do power on self-test, post. To make sure the tal hardware or working BIOS will then look for a small sector at the very beginning of your primary hard disk called master boot record, MBR. The MBR contains a list, or map, of all of the partitions in your computer's hard disk, or disks. After the MBR is found, the bootstrap loader follows basic instructions for starting up the rest of the computer, including the operating system. In early kernel initialization stage, a smaller core of the kernel is activated. This core includes the device drivers needed to use computer's RAM chips. BIOS firmware is stored in a ROM/EPROM, erasable programmable read-only memory chip known as firmware on the peak motherboard. BIOS can be accessed during the initial phase of the boot procedure by pressing the F2 or F10. Finally, the firmware code cycles through all storage devices and looks for a bootloader, usually located in first sector of a disk which is 512 bytes. If the bootloader is found, then the firmware hands over control of the computer to it. UEFI stands for Unified Extensible Firmware Interface. It does the same job as a BIOS, but with one basic difference: it stores all data about initialization and startup in an .exe file, instead of storing it on the firmware. This .exe file is stored on a special partition called EFI System Partition, ESP, on the hard disk. This ESP partition also contains the bootloader. UEFI was designed to overcome many limitations of the old BIOS, including UEFI supports drive sizes up to 9 zettabytes, whereas BIOS only supports 2.2 terabytes. UEFI provides faster boot time. UEFI has discrete driver support, while BIOS has drive support stored in its ROM, so updating BIOS firmware is a bit difficult. UEFI offers security like Secure Boot, which prevents the computer from booting from unauthorized/unsigned applications. This helps in preventing rootkits. UEFI runs in 32-bit or 64-bit mode, whereas BIOS runs in 16-bit mode. So UEFI is able to provide a GUI, navigation with mouse, as opposed to BIOS, which allows navigation only using the keyboard. User Interface Mechanism. A user interface, UI, controls how you enter data and instructions and how information is displayed on the screen. There are two types of user interfaces: 1. Command line interface, 2. Graphical user interface. Graphical user interface. With a graphical user interface, GUI, you interact with menus and visual images. Command line interface. In a command line interface, a user types commands represented by short keywords or abbreviations, or presses special keys on the keyboard to enter data and instructions. 1. Batch operating system. 2. Time-sharing operating system. 3. Embedded operating system. 4. Multi-programming operating system. 5. Network operating system. 6. Distributed operating system. 7. Multi-processing operating system. 8. Real-time operating system. Types of operating system. Assignment. 1. Batch operating system. The users of this type of operating system does not interact with the computer directly. Each user prepares his job on an offline device like punch cards and submits it to the computer operator. There is an operator which takes similar jobs having the same requirement and group them into batches. 1. Batch operating system. Cont. Advantages of batch operating system. Processors of the batch systems know how long the job would be when it is in queue. Multiple users can share the batch systems. The idle time for the batch system is very less. It is easy to manage large work repeatedly in batch systems. Disadvantages of batch operating system. The computer operators should be well known with batch systems. Batch systems are hard to debug. It is sometimes costly. The other jobs will have to wait for an unknown time, if any job fails. Examples of batch-based operating system: IBM's MVS. 2. Multi-programming operating system. This typavosis used to execute more than any job simultaneously via single processor. It increases CPU utilization by organizing jobs such that CPU will waste in Egypt to execute multi-programming operating systems. The mechanism of scheduling and CPU scheduling. 3. Time-sharing operating systems. Multitasking system. Each task is given some time to execute so that the tasks work smoothly. These systems serials are known as multitasking systems. This can be from a single user or different users. Also that a methodic task gets to execute is called quantum. After this time interval is over, switches over to the next task. 3. Time-sharing operating systems. Cont. Advantages of time-sharing OS: each task gets an equal opportunity, fewer chances of duplication of software, CPU idle time can be reduced. Disadvantages of time-sharing OS: reliability problem: one must have to take care of the security and integrity of user programs and data communication problem. Examples of time-sharing OS: Multics, Unix, etc. For multiprocessor operating systems: multiprocessor operating system serial SoC known as parallels or tight-like couplitos. Such operating systems have a more than an processor in close communication that sharing the computer bus, the clock, and sometimes memory and peripheral devices. It executes multiple at the same time and makes the processing faster. It supports large physical address space and larger virtual address space. If a processor fails, the other processor should retrieve the interrupted process state so execution of process can continue. Inter-process communication mechanisms provided and implemented in hardware. 5. Distributed operating system: various autonomous interconnected computers communicate with each other using a shared communication network. Independent systems possess their own memory unit and CPU. These are referred to as loosely coupled systems. Examples: Locus, Dcirc. 6. Network operating system: these systems run on a server and provide the capability to manage data, users, groups, security, applications, and other networking functions. These types of operating systems allow shared access of files, printers, security, applications, and other networking functions over a small private network. The other computers are called client computers, and each computer that connects to a network server must be running client software designed to request a specific service, popularly known as tightly coupled systems. 6. Network operating system advantages of network operating system: highly stable centralized servers. Security concerns are handled through servers. New technologies and hardware upgradation are easily integrated into the system. Server access is possible remotely from different locations and types of systems. Disadvantages of network operating system: servers are costly. User has to depend on a central location for most operations. Maintenance and updates are required regularly. Examples of network operating system are Microsoft Windows Server 2003/2008/2012, Unix, Linux, Mac OS X, Novell NetWare, and BSD, etc. 7. Real-time operating system: these types of OSs serve real-time systems. The time interval required to process and respond to inputs is very small. This time interval is called response time. Real-time systems are used when there are time requirements that are very strict, like missile systems, air traffic control systems, robots, etc. 8. Embedded operating system: an embedded operating system is built into the circuitry of an electronic device. Embedded operating systems are now found in automobiles, barcode scanners, cell phones, medical equipment, and personal digital assistants. The most popular embedded operating systems for consumer products such as PDAs include the following: Windows XP Embedded, Windows CE.NET. It supports wireless communications, multimedia, and web browsing. It also allows for the smaller versions of Microsoft Word, Excel, and Outlook. Palm OS. It is the standard operating system for Palm brand DAS as well as other proprietary handheld devices. Symbian: OS found in smart cell phones from Nokia and Sony Ericsson. Popular types of OS: desktop class Windows OS X, Unix/Linux, Chrome OS, server class Windows Server, Mac OS X Server, Unix/Linux, mobile class Android, iOS, Windows Phone. Desktop class operating systems platform: the hardware required to run a particular operating system. Intel platform, IBM compatible, Windows, DOS, Unix, Linux, Macintosh platform, Mac OS, iPad and iPhone platform, iOS. MS-DOS single user single tasking OS. It had no built-in support for networking, and users had to manually install drivers anytime they added a new hardware component to their PC. DOS supports only 16-bit programs, command line user interface. So, why is DOS still in use? Two reasons are its size and simplicity. It does not require much memory or storage space for the system, and it does not require a powerful computer. Microsoft Windows. The graphical Microsoft operating system is designed for Intel platform desktop and notebook computers. The best known, the greatest selection of applications available. Current editions include Windows 7, 8, 8.1, 10, and 11. Mac OS user-friendly, runs on Mac hardware. Many applications available. Current editions include Sierra, High Sierra, Mojave, Catalina and Big Sur. Version 11, released in November 2020. Linux, an open-source, cross-platform operating system that runs on desktops, notebooks, tablets, and smartphones. The name Linux is a combination Linus, the first name of the first developer, and Unix, another operating system. Users are free to modify the code, improve it, and redistribute it. Developers are not allowed to charge money for the Linux kernel itself, the main part of the operating system, but they can charge money for distributions, distros for short. Google Chrome OS. Chrome OS is a popular thin client operating system. Thin client, a computer with minimal hardware, designed for a specific task. For example, a thin web client is designed for using the internet. Server operating systems. Windows Server. Familiar GUI interface for those experienced with Windows. Unix. Very mature server capabilities, time-tested, large user community, stable. Linux. Free, customizable, many free services and utilities available. Windows Server. Unix. Tablet and phone operating system. System on chip, SoC. An operating system that comes pre-installed on a chip on a portable device such as a smartphone. Popular SoC operating systems. iOS, for iPad, iPhone, Android, for a variety of tablets and phones. Downloadable applications, apps, from an app store, for example Apple App Store, Google Play Store. iOS on the iPhone and iPad. People create operating system for applicable smartphones. The current stable version iOS 14 was released to the public in September 16, 2020. Unknown anot December 13, 2025, 14:04 and 17 seconds plus 03:00.